I'm John. I forgot to get a name tag and introduce myself this morning. I was busy up here. But I've been working on this project since its conception 11, 12 years ago. And I've really taken to the whole building side of it all and helped with about 4 Earthships around Europe. One never got finished, so three solid ones. So today we're going to be doing a short practical section in rammed earth car tire walls. And tires, there's a few things you have to know about them. They're measured in a funny way. There are measurements on every tire on the wall of the tire here.
Oh.
And this is a pre-used tire, needed a bit of a wash there. So the first thing I want to say about tires actually is that, you know, in England we produce about 45 million waste car tires per year, and that's like 3 tires for every 4 people in the whole United Kingdom. So they're a massive waste issue, and in July of 2003 the Environment Agency cast a moratorium on waste tires being dumped anywhere in England or in the UK. So what we've been needing to do is to get rid of them other ways. Now, there have been lots of harebrained ideas, like shredding them and putting them in bales and trying to make artificial reefs form around them in the water, and things like ridiculous things. That was like one of the most forward, people were trying to really push that one forward. The only other really clever use I've ever seen, to be honest, aside from in rammed earth car tire walls, is those South African sandals. It's probably the only footwear you'll get a 20,000 mile warranty on.
They use them for schools, because I ride someone else's horse and they use them now, all chopped up. And they're lovely and bouncy.
Yeah, for playgrounds.
No. Horses, arenas.
Oh, yeah, menageries and things like that.
Yeah, brilliant. Absolutely brilliant, though.
Right. The trouble is, the trouble is that rubber will break down when exposed to light, UV, and water. So it will leach into the ground harmful things when exposed like that. And you certainly shredding them, increasing the surface area, and the rest, it's a rapid process.
I get gas there when I go around.
That's why they're classified as toxic waste. And when you get your car tires changed, you pay an extra couple pounds for the disposal of each of your old tires. Michael Reynolds, when he came up with the idea to use them as a brick in a house, he was looking at what does every city in the world have a mountain of next to it in terms of indigenous waste, and his answer was tires. And so he came up with the idea to ram them full of earth and lay them like bricks. The first advantage being that, first of all, they're really wide bricks, so the increased surface area means that you don't need a foundation, unlike a block and brick wall where it'll sink into the ground under the weight of the wall. This really spreads the load, and so on virgin, undisturbed ground, you can just lay your empty tires in situ, of course, on top of a dam-proof membrane, some kind of tanking under the wall, and then ram them full of earth with the spoils of the excavation from your site.
So where do you get your tires, though?
Yeah, that's typically. I mean, I've done a lot of different, not just Earthship buildings, but just like small community projects, retention walls, and things. If it's a small-scale project, all we do is we go to the local Quick Fit or whatever, and I don't know if this should be recorded, but the truth is that the guy will kind of you'll say you want the tires, you explain your purpose, and he'll look out, he'll look left, he'll look right, and he'll just start ushering them into your vehicle.
How many they can give you?
As many as you want, and you want a certain size. Okay, so you have to sift through what's there and get the ones you want. In Holland, they did it really cleverly. They planned their Earthship building well in advance. They got in touch with a waste transfer company that dealt with tires, and they said they want like 1,000 of this size. And the waste transfer company came with lorries, and there they were. So if you're building a house, it's good to go through the proper procedures, obviously, in any case. But that is
waste company.
Yeah, a waste transfer company that handles tire waste. Yeah. So first thing is when you're working with bricks, it really helps if they're all the same size. I mean, you can build stone walls and stuff, and some people are really good at that. But with tires, it's a little more tricky. So you want all of your tires on each course, each line of bricks you're laying, to be all the same size, because that way you don't get all these different level variances, and your wall comes up level, which is what you want. And we're going to learn how to do that today. So the three measurements on a tire are, the first number there is the millimeters of the tread depth. Okay, so 195 millimeters in this case is this distance. Now, when you're ramming them for making a wall, you would only work within a certain range. Anything lower than 185 and below is they're so small and light. Even when they get pretty full of soil, they jump around a lot. They'll move anyway when you're working, but you just like the less the better. So I'd say a minimum size of 195, and then of course you don't want to be there all day doing one tire, so a maximum size say of 235. Better if you can get them all the same, because obviously it works out better mathematically. The whole wall will go up more consistently the way you want. However, there is use of different size tires. It's good to have a few different ones as well, but I'll explain that as we go. So the first number, 195, that's the tread depth. So even when they're rammed solid, they all expand about the same. However, the second number has a part in that, and that's, you see the slash there, that's 65% of 195 millimeters is the wall height. Okay, so there is such a thing called a low profile tire, and I would say anything that's below 60, say, is a low profile tire. So 55 or less % of the tread depth is a low profile tire. Now imagine if this was a low profile tire, so we had less measurement here. When you ram this thing, and this one can go up and puff up a certain amount, a low profile tire will have a lower ceiling of how much it can expand. So you never want to use low profile tires because it just makes, again, an inconsistency that's hard to deal with when you're making your wall. So 60 plus on the percentage. The last number, this is funny, tires, you got millimeters, percentage, and then the rim size, here it says 15, so you can guess, like, that's a measurement, it's 15 inches. So you got millimeters, percentage, and inches. For some reason, it must have been like an EU kind of US agreement. They would meet halfway, I don't know, but that's the way all tires are measured in the States and here. So this rim size, 15 inches, that will affect the overall diameter of the tire, as does the wall height. Okay, so different wall heights are gonna increase or decrease the overall diameter as well. So these two figures affect the overall diameter of the brick. Now that's important when you have like with all brickwork, you don't stack them up like this. You want the wall to be knit together, so you stagger the joins, so you have one tire straddling two below as your second course and upwards. Now, I don't know if anyone noticed the back wall of the building when you're in the classroom, that it's leaning back. Mm-hmm. We followed a formula of a 1-inch batter. So that meant the first course was laid outlining the northeast and west walls, and then every course after that steps back 1 inch from this plane, okay? So from these front edge of the tires, if you were to put a straight edge across that and go up vertically, this went back 1 inch every course. That's what that lean is, about 10 inches from the floor to ceiling, because it's 10 courses high. So you have the first outline of the northeast and west walls, and then you have the second, third, fourth, fifth courses, and you can see what's happening here is the overall circumference is increasing. So invariably, every tire wall I've ever worked on, you end up with these gaps, where you these necessary gaps that have to happen because of the overall circumference increasing as you go. Now, you never want the gaps to be like a zipper up in the same part, so you have to stagger them around the wall and space them as far apart as you can. So if you're working, got a lot of people on site, sometimes you will look around in your tire hoard for some with a larger rim size and a larger wall height that have a greater overall diameter to increase the distance you're going with each brick you lay, to kind of spread that gap away from the other gap. Does that make sense? Yeah, I tried to explain it as best I could. So there's where those second two numbers can come into play.
So why do you go 1 inch further?
The engineers almost always specify around 1 inch. In Scotland they specified 40 millimeters, so that's over 1.5 inches. He was just really covering himself, because what you have is you don't have a mortar join. Okay, so these tires are rammed in situ, and they swell on their undersides. You can see, look at that bulge below where one tire is straddling two. It's got this kind of nib that forms like upside down Lego in a way, and that is the interlocking shape of the tires, and the sheer mass, the rubber contacting rubber, the weight of the bricks. That is the structural integrity of a rammed earth wall. Whereas a normal brick wall, they slather mortar and glue in essence the bricks together. So engineers require, in this case of this style of building, like a dry stone wall. I don't know if you've ever seen a dry stone wall, but they're fat at the bottom and they're all kind of falling into the center. So this wall is leaning back into the burial berm. So that is added strength, structural strength of the wall. Yeah. Oh, and sometimes they require a buttress as well, which will be like either a post leaning into the wall. In Scotland, again, the engineer was way over the top. He made us lay breeze blocks in a stepping fashion to buttress the wall and make sure that any downward pressure, hydrostatic pressure from the water flowing through the ground or whatever, won't push that wall forward and break it open. So that's just to reinforce the strength of the wall. So you're here to do practical work. It's not just for me to talk at you. So I'm going to demonstrate what we first need to do. So you put your first course of tires when you start your build, outlining the profile of what you're trying to build on the damp-proof membrane underneath of them, but just straight on there, and you start filling them with the spoils of the excavation and then ramming it with the sledgehammer and puffing them up until they're like a rock wrapped in steel belted rubber. But after you get off the ground, your second course upwards, what happens when you start to pour earth into this tire? It just wants to come out through this void here, doesn't it? So a temporary floor we put into the tire. And we use a recyclable product, cardboard. So cardboard, in a kind of way, like wood, it has a grain. The corrugations sandwiched between two paper membranes kind of run this way. They run this way on this one, and the strength is less this way than this way. So I'll lay this first one in. It's helpful to bend it and then try and get it in there, and then unfold it inside. I've chosen a really tough piece of cardboard to demonstrate, but it's doable. Okay, so that is a really hard piece of cardboard. I'll just do another one just to give an example. Typically you need 2 to 3 layers, and not all cardboard's created equal. The test you then do is a kick test. Now, that way, I know it's not, I didn't kick it with all my might. I mean, I may have been able to kick through that if I really tried. The important thing is that you do that kick test, because the last thing you want is to spend ages up there pounding the tire and then have a blowout in terms of a tire wall construction, which means the cardboard gives way and the soil starts coming out through that void I demonstrated, and then you have to take the tire off the wall, empty it, start again. So you want to make sure, cardboard's one of those things you can get heaps of, it's free, so just put plenty. 4 layers if it's thin stuff, and 1 or 2 if it's really thick, like that. Okay. So the first thing I'll have you all do is start putting that cardboard in these tires, and then we'll start laying them on the wall. Now what we've come to here...
Can you tell us a little bit about your soil? What are they?
This is chalk.
Chalk.
That's been had some soil mixed in with it over time. So when we first dug out this site, we were the first Earthship in the world to be a rammed chalk building. It's not rammed chalk tire building.
You brought it here, or you?
No. This is what's under your feet. Everywhere in Sussex.
Is it?
Everywhere in Sussex is under about 6 to 12 inches of soil is chalk. Get some cardboard, start filling some tires, and then we'll start laying them on the wall. One straight edge here. It doesn't have to be a spirit level on this one. It doesn't. We're not looking at that bubble at all. this is the one we're going to look at here, because we're trying to establish a plumb line, a vertical line going straight from this plane, where we've made an artificial straight line from the edge of that tire to the edge of that tire. I make sure that they're flush here, and then I start to look at putting it level. So I'm making sure that's staying flush. And then I'm pinching the level between my thumb and forefinger here. And then I'm using this finger to steady the level so that it doesn't wobble all over the place. I'm looking at the bubble, and there's my plumb line. So that's almost in line completely. So I need to go 1 inch back from that line. So that's about 2/3. A little bit. Okay, I'd say that's about 1 inch. It doesn't have to be exact. You could, a clever fellow in Scotland, I mean, we were doing this just this way for ages, and we met, one of the volunteers up in Scotland on the Greenhead Moss Earthship that unfortunately suffered an arson attack after it was nearly completed, the shell. He came up with, his name was John Gage, I think, and John Gage's gauge. He basically made this, he fastened two pieces of wood together like this. He put a little 1 inch outstand on it like this, and he just fastened a little level correctly on that edge. And you had this tool that you could just put up to the tire instead of this propping it with your knee business. So yeah, clever idea. Definitely worth making one if you're going to build any rammed earth tire walls. Now, on a curve, we do this at every tire, because obviously, unless you cut a big wooden profile, that you could then kind of use. But on a curve, you've got to check each one. And then on a straight line, of course, you'd finish 2 tires on the ends and run a string line across, and then you can just pull all the rest on the straight line to that string line. Yeah. So the tires also, when they're placed, they have to be touching. So you want to make sure that you put one tire, check that it's 1 inch batter back, then put your next tire, touching that tire, and again the 1 inch batter, and so forth. And you have to work in that kind of order. Okay. So I asked for these to be in buckets because whenever you're working with a dangerous tool, something like a sledgehammer, if this even glanced my head or someone else's head, it could kill us. So we want to have spatial awareness. We always have a rule in working with tire walls that you never work next to each other. You always have at least one empty tire or one tire that's not being worked on between you. So we wouldn't have somebody here and here. I probably should have started that there, but here I am. Fill those buckets again as I'm talking. And so at first, what we have here is, some loose soil piled into a tire. And we want to get it into all the edges so that we can then start adding more. Now, this can be done doing the tire dance, which I'm not going to do because I'm suffering a meniscal tear in my knee. But you can go around while the soil is still loose, and you can kick it into all the edges, the void of the tire here. So you can go around and you can really do the tire dance, they say, and just, have a bit of fun, kick the dirt in. But then we're ready for some more. So if you don't mind, Patrick, please, dumping that one in. I'll see about the second one in a moment. So I don't want to pour any more because it'll just spill on out now. So I could carry on doing the tire dance maybe if I had strong, my legs were in good condition right now, but I'm not going to, so I'm just going to step right in with the hammer and start to show you that. Now, the first tire I ever did took me almost 2 hours and it still wasn't quite level. I did one in 12 minutes by the end of 4 months of volunteering on this job. So there's definitely technique that will speed your process. Now the real trouble is if you just have at it from your most comfortable position right here, and say you're right-handed, this side of the tire is going to get really rammed up full, and then you're going to try and level that bit with that bit, and you want it to be a level brick by the end, like all these tires. So the way I do it is I transpose a compass rose with my mind's eye over the tire. So that's north, northeast, the 8 directions, just an arrow with 8 arrows, going out from the center. And I put equal attention to each of those directions as best I can. Now, the idea is to really ram this part here getting this to be tamped solid is no problem. You know, you can just kind of tamp soil like that. But getting the rest of the tire, all of it, to be full and completely rock hard, you need to really send the earth in that way. So the first thing is just to drop your sledgehammer in the center, compacting some of the soil there. And then as you're working out in one of your directions, you start to change the angle of the hammer shaft to be more vertical. So you notice that I was dropping it and the hammer shaft was almost horizontal, and then as I move it toward the edge, the hammer shaft becomes more vertical. So what I'm doing in effect is I'm packing it from the center into every direction like that. Pack, 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 pack. Okay? So there I go, going around in my compass rose directions. Start to work over here. Now when it's really loose like this, you can just have at it like that. You can even use the side of the sledgehammer head if it seems to be really powdery and you want to get a greater surface area, packing it in there. You see I'm changing positions, even my hands. It's a good idea to switch hit, otherwise you get a bit tired working one way. Okay. So I don't want to just stand up here and work from this position, because how on earth can I pack equally with equal force over there from this position as I do from this way? So again, I need that next bucket.
What do you step on when you are quite high up?
Yeah, I'll demonstrate that in a second. What we did on this building was we actually built a scaffolding walkway. But that's the only time I've ever seen that on the 4 jobs I've worked on actual buildings, and smaller ones didn't need it. But you get your heel in here when you're up a wall, and indeed some Earthship designs have a tire wall going straight in from the main buttressed wall into the, just to divide rooms. A partition wall stems out from that back wall, and you've got nothing either side. And before it gets packed out, you're up on the 10th course, and the wall's doing this, and you're swinging a big lump of metal.
Oh yeah.
Yeah, it's quite a circus act, but we managed. Yeah. So I would carry on like that in every direction, and just keep going until I end up with this. So that's how you do it. And there's a few other tricks and things. Sorry?
How many buckets do you need generally?
Surprisingly,
Quite a lot.
a lot. Yeah, you'd be amazed because this was chalk. When we dug it out, it was all lumps of chalk with lots of air pockets between it. Someone calculated on the big tires on the bottom course, which the larger the tire is, really increases a lot. The amount that goes in. These are 195s on the low end of the lowest end of the spectrum. 4 wheelbarrows of chalk into a 235, and you know it just keeps swallowing it, you know, because you're compacting those lumps of chalk with all the air pockets between them back into a solid mass. Each one weighs about 300 pounds. You know, it's a lot of mass in there. So what I'd like is for somebody to start working on this one, and then someone over there, and then we'll get those other tires laid here, so the first people that want to start pounding can get them in position, use the 2 levels, do the batter, starting from this position here, 2 tires touching, and then outwards from there. We can only do 1 here because we got to stop before those are done. We can go all the way over to there with that side, okay? So a hammer, you know, it's a really solid lump of metal, and I like to use this quote from my landlord, a retired bricklayer in his 70s. You know, man lifts it up, or woman, and God lets it fall. So you are the one that wants to lift it up as easily as possible. So if I try and lift it here, obviously I'm really struggling because leverage is against me. If I move my hand close to the head of the metal, I can lift it with great ease, and then I can lift it over my head with great ease, and then I can let it fall with a lot of force. Now, I've seen men, women, and children of all walks of life do varying degrees of success with this. And in one case in particular, I saw a giant man struggling and a really petite woman racing ahead of him with her work. So it really is about technique more than strength. And everyone will get tired really rapidly if you keep your hand locked in one position. This kind of motion is not only going to shock your wrist and make your whole upper body really strong, really tired really quickly, it's just the least effective way to use this tool. So lift it up, swing it down. Now you notice that as it's making contact, I've got my hands locked, anchored on the shaft of this hammer at my center of gravity. So when I work, if I move my center of gravity to the right all my body mass is anchoring that swinging pendulum and really ramming it into that spot. So do it slowly and deliberately at first. Really take your time to get the technique, because if you do that, you will have 10 times as much force as if you're doing this. And you'll be able to do it all day long because you're not using as much strength. So have a go at just slowly and deliberately trying to get that technique down, and then you'll start to feel the rhythm of it. So these ones need to be staggered. So where's the hole below? So there, it's going to end up somewhere like that. That one there. And then another there. But we'll get them all in line. You don't want that because it's quite straightforward. You fill it with earth and you tamp it down. Also you're bringing up the damp-proof membrane and the insulation layer as you work. So we have a big damp-proof membrane wrapped under this wall, up the back, close to the back edge of the excavation there, and it would be rolled down, and we'd unroll it each time we went up, and keep it tidy, covered with carpet, usually old carpet to stop flint or any stones from puncturing it as you're working. Use a double layer, that sort of thing. And the insulation board is rigid insulation, so that's got to be all pieced together as you're going as well, and brought up with the build. Now I also, while we've got, somebody can step up there, while we've got you all standing as well, there's only one really effective way to get a tire wall done really quickly. Everybody, when you get a lot of people on site, especially paying volunteers, you're not paying them, they're paying you, typically is what the formula has been for a lot of these kind of builds, because so many people just want to learn. Yeah. So yeah, it's a great formula, isn't it? You know, people pay you, you just feed them and tell them camp in the field or whatever, and then they come over and work all day for you. It's wonderful. So everybody wants to get up on the wall with a hammer right away. It will go really slowly if everyone's just doing what they want and so forth. The only way to do it, you've leveled your ground as we just described, got the flat area, we lay all of our tires empty in situ, outlining the northeast and west walls of the building in this climate, so we get that south-facing glass. And then you've got all the volunteers are donning the hat of the soil bearer, and one person is running back and forth, kicking the soil into the tires as all the other people bringing soil. So you have 10 or 12 people. You have 11 doing the soil bearing and one kicking it in, and he's able to, or she's able to keep up with all those people, because at first it's so loose you can just push it in 1 second, 2 seconds, and then they have to come with more buckets already. So you can like run up and down the wall while you've got all these soil bearers filling the tires, and you can keep up with all those people bringing dirt. So then soon they overtake that one person on the wall. Then you divide the wall in two. One of the soil bearers steps into the role of tire pounder, and they start picking up hammers maybe at that point, if you can't do any more by hand or by foot. And then soon those two tire pounders are overtaken in terms of the work being done by the remaining 10 soil bearers. And then you divide the wall into 4, and then it's so forth. Until finally, toward the end, you've got one person serving soil to 2 tire pounders. So that's the equation. And if you follow that, and you get all of your empty tires laid out, your walls will fly up. They will literally fly up by comparison to everybody just having at it any which way they like. So that's the only way to get the walls done in an efficient manner. You can do windows. If you were doing like they do the huts in countries that are cold, and they just put little windows because that are hot, like the equatorial kind of climate. They don't want a south. They don't want the glass. They bake. So they have little windows, and you just frame them in the cavity. So what your question is leading on to is, how do you make the plumb end of a wall? Plumb meaning, how do you terminate a wall at a vertical line. Okay, because look, here we've got a step. So then you only have room for a half brick. How do you do a half brick? So the way you do a half brick is quite simple. You take some lath, which is like extruded metal lath, which is just like, it looks like a fence, but really tiny little almond shapes or leaf shapes, you know, where the metals were pulled apart. Chicken wire kind of stuff. And you make a form. You screw it to this part and this part, and you wrap it around this. And it makes like the form of a half block, and it's at the height of the finished tire on the end. And then you fill it with concrete and rocks and things. That's again the quick and dirty method. And then you have a half block, and then the next course you put a tire there, of course, on the hardened concrete. You can also cut a tire and leave flaps and screw it in and ram it like that. So that's another method, a more labor-intensive method. Let's check with the tire next to it. Okay, as I suspected, this tire next to it's been like worked on and it's kind of been pressed down over time. So even though we pounded this one as we should, solidly, we now need to just give it a tamp down so we can come to that level. But also, we need to make sure it's level with itself. So we're going to check against this and get a point that's the right height to match in with this one. And then from that point, we're going to check the tire against itself and make sure it's level in every direction. Because you want your brick to be level, front to back, side to side, etc. You don't want your wall like wanting to tilt this way or that way. You want every course to be level. So the next job then is, I can tell this one's too high, so as hard as it is to pound it up, it's really easy to pound it down. There's no way I can just push this tire like that. So I've got to do a little bit that side, a little bit that side. If I only work one way, it'll spin like this, and the nibs that are front and back would go out of position and it would start rocking. So I've got to give it a nudge that side, a nudge that side. Likewise, if I was going forward, I'd have to nudge it that way, so that I never changed the way it was sitting, because those nibs underneath would start to rise up onto the tire there, and the whole thing would start to rock and it wouldn't work at all. So that's how you do that. And then there's another method. Now, this is something that happens. Now imagine, have you noticed on the front of the building we have what are called wing walls?
Yes.
Now those walls fan out from the modules because we have water coming down, especially on a chalk landscape. It's like rivulets running through the chalk when it rains really hard. And these wing walls come out and they make the water take a wide berth of the building, yeah? So you don't get pooling around the front doors. So that's the purpose of those wing walls. Now, when you have a wall that goes like this and then kicks out like that, it's called a return. And then you'll have the tires starting to make the turn, yeah? So we want to say this is an exaggerated turn here, but then I want to put my next tire here. Say it's going like that, and I put it here. It tends to have more hanging over the outside edge, so as you're pounding it, it keeps wanting to just fall right off the wall. Now, the way to kind of avoid that happening, I mean, is you have to just keep moving it back a bit, but then also, say it also doesn't have as much to support it underneath here. So one way we deal with that is the next creatively named technique is the shovel technique. And what we do is to kind of prop up this tire by making it have little legs or feet down here and here, so that it props itself up on kind of two little feet there, is we'll have one person drive the shovel in. Now mind you, this will be full of soil and stuff, and lift it up like this, and then another person striking sledgehammer blows this right in that direction, the force going like this at this angle, so that it's pushing the bottom tire wall down. So you create these two extra little divots to kind of let that tire stand itself up on the purchase it does have. You all got that?
Yeah.
So that's all my tricks basically. I mean, there's a few more, but I just wanted to share that. I want to talk about how you join wood to rammed earth tire walls. Now you want to frame your building, your roof trusses or I-beams or rafters, whatever you want to call them, what you're using in your design, have to marry wood to this surface here. So the way it's done by Mike Reynolds is he has a reason why he does it this way, because it's actually the poorest choice in terms of environmentally and labor. It's much more labor intensive what he does. He has a lot of volunteers on his site. He's like a celebrity builder, isn't he? So he's got like armies of people wanting to join and paying interns and all this kind of thing. So he's got to keep all these people busy. On a Michael Reynolds Earthship build, there'll be 40, 50, 60 people on site sometimes.
Wow.
And you've got to keep these folks busy. So what he does is he makes, on top of the Tyre wall, when it's all pretty much level at the top, one advantage of his technique is that you don't have to have it perfectly level. You always strive to make it perfectly level, but because he does it this way, it's not absolutely crucial. He has all the volunteers mixing up cement, and he builds two, like a trough, two little dwarf bottle walls all the way around, making a trough in this area here. Okay? Now first, before he's done that, of course, he's driven 1 meter long spiked metal rods, rebar it's called, is driven down, so you have these upstands of metal coming out through after being driven down through 3 courses of tires, there's this final little upstand of metal, and then he wires 2 strips of iron rebar in long lengths, suspended off of the Tyre wall by about 6 inches along there, and I don't know if you get it already, but then he makes this trough and then fills it with concrete, you see, and that allows him to level that trough perfectly, you see, so the top of the Tyre wall could be a little bit out, but his team is so good that it's almost always perfect when they finish, you know, it's like a tabletop looking across the top of the wall. So then you've got this, what he calls a concrete bond beam, a steel reinforced concrete bond beam that links all the wall together from the top, all these spikes of metal, and when the concrete is first poured in, it's still wet and soft. He drops little anchor bolts in, usually like an L-shaped piece of metal with threads up here, sink it into the concrete so that just the top of the bolt sticking out with its threads, and then you can put a wood plate on top of that and you can screw it down with a nut, yeah? So you've got all these little anchor points, and then you can basically you just offer up your big timber plates to once the concrete goes hard, you've got all these little bolts sticking out, and you offer up your big plate and you tap it with a hammer above where it's resting on the tops of these bolts. It makes a little impression on the wood. You flip the wood over and you drill a hole through in all the points where the bolts have made an impression, and then you can simply drop that wooden plate straight onto those bolts and then screw the nuts on with a washer, and you've anchored the wood plate to the concrete bond beam that's anchored by long metal rods into the wall. And then of course you can just screw your roof trusses into that wood. So you've got a timber roof joined in that way to the rammed earth wall. What we did here, because we all thought that's just a really excessive use of concrete and cement and bottles and labor and the rest of it, we leveled our top wall, we got it really perfect, and then we just hammered, instead of just straight metal rods, we hammered threaded rebar, which is the same thing, like a long metal bolt. You can get it in long lengths. We cut a point on it and we hammered it down through the tires, like Michael Reynolds does the metal rods. And the only problem with the way we did it, it was a little bit more fiddly, is that invariably as you're hammering a 1 meter long metal rod down through this mass of rock and rubble and tire tread and the rest of it, it almost never goes perfectly vertical. It always kicks out some way, and you've got it coming out the top. Instead of like when you sank those little anchor bolts in the concrete, you set them exactly plumb, exactly vertical, yeah? So you can get that almost precisely vertical just by sinking them into the concrete and letting them go hard like that. The way we did it, all these metal rods coming out with threads on them, all in different directions, yeah? So they weren't all just leaning that way or all leaning that way, they were some leaning in different directions. So then how do you get a piece of wood to sink down over something pointing out that way and that way? You can drill 2 holes there, but it wants to go like that, doesn't it? It's not going to go there, that way.
So what you have to do as well then is take a jigsaw after you've drilled your hole and cut a channel in the direction. So by eye, you have to start looking at which way is that bolt leading for that hole, and you have to cut a channel so that when you sink the wood over it, see this channel here, it can just go down over it like that, and then you can screw your nut down onto that. Okay, so it's a fiddlier job, but you save tons of concrete and loads of labor making all those two dwarf bottle walls as a trough, and it's just much more eco, isn't it? So I would highly recommend you follow that method in your Earthship reeds. Okay, I hope you all enjoyed the practical section. Thank you very much. Well done. Great, thank you.